Okay, I just wanted to post a quick video for my business math, uh, 6.4 to 6.6 matrices. I did some, I did a video over the notes in chapter 5, uh, some word problems and some applications, but there's also 6.4 to 6.6 that goes to this next exam. So I just wanted to walk you through this a little bit here. I'll upload this picture of these notes to Blackboard soon enough, but for right now, a matrix is defined as rows. Sorry, it's so small here, but you could zoom in on your own later. Rows going across, R1, R2, and then columns going up and down vertically, C1, C2, C3. So the number of rows here is 2, the number of columns is 3, so we say that this is a 2 by 3. 2 is the number of rows, 3 is the number of columns. Again, C representing columns, R representing rows. Usually a matrix is named by a capital letter, capital A, capital B, capital C, and so on. Aij, just for notation, the little I, little j, those little numbers here down here, they represent what row and what column you're in. So for instance, A32 means third row, second column, which is -8. A12, first row, second column, 1. A41, fourth row, first column, 4, and so on. Again, now to do operations with them, with the matrices, if you want to do addition and subtraction, they must have the same exact order. Means they must be the same size boxes. So matrix for us is like a box with numbers here. So this first matrix has 2 rows by 3 columns. Second matrix has 2 rows by 3 columns. This would be addition. So you add the first number in the first row, first column of the first matrix to the first number in the first row, first column of the second matrix. So that should have been 3 plus 9. It doesn't make any difference because it really is commutative, but let me change it here. 3 plus 9. It doesn't matter the order, but it's the first one plus the first one. And then the second plus the second, 4 plus 5, -5 plus 8. Second row, -2 plus -6, 1 plus -8, 6 plus 0. When you do the additions, you get these 6 numbers. These 6 numbers represent the solution. That's all it is. Subtraction as well, 2 rows by 2 columns minus 2 rows by 2 columns. So 8 minus 4, -3 minus -6, -2 minus 7, and 5 minus -2. And then you compute it up, and you get those 4 numbers as your one solution. Now number 3, notice how the first matrix has 4 rows by 3 columns. Second matrix has 3 rows by 2 columns. There is no possibility to do so if they don't have the same order. Okay, so these are this different order, so it's not possible. Okay. Multiplying by a scalar. A scalar is a fancy way of just saying a number outside the box multiplied to the box. It usually magnifies it or minimizes it or changes it to the opposite direction. So you multiply every entry in the matrix by the scalar. Again, the scalar would be the number outside. Just the number multiplied to the box. So in essence, it's like just multiplying that number to all 4 of these numbers inside, which you see the individual multiplication, -2 to each number. You multiply them and you get this answer. And again, this is a 2 by 2, just let's put that in there. And so the solution is a 2 by 2. That's not a huge importance here. 5 times these 6 numbers in this box. Again, it doesn't matter how big the matrix is. Just multiply 5 times each number inside. And this one, you multiply each number inside by 1/2. So when you have a fraction, these are integers. It basically means put each number over 2, essentially. And then simplify. 4 over 2 is 2, 6 over 2 is 3, etc. And that's all it is to it. Pretty straightforward. This part is really the 6.4 part. Addition and subtraction of matrices. That's really the 6.4 part. And it's very brief, so I just thought I'd walk you through a little bit, and I think you should be able to pick up on this pretty good. Multiplication of matrices, a little bit more complicated, but nothing too fancy. To multiply 2 matrices, the number of columns of the first matrix must match the number of rows of the second. The columns is the second number, remember? The rows are the first number. So it's basically saying that the second number of the first matrix has to match the first number of the second matrix. All it has to do is those two have to match. Once they match, you can do it. If they don't match, as example number 3, you can't do it. if the interior numbers do not match, essentially. So here, once you can do it, you multiply the numbers that are in the first row, or by the numbers that are in each row, by each individual column. It's like you're multiplying row times column, row times column, row times column, row times column. So the outer two numbers tell you how big the answer is reading from left to right. So the answer is going to be a 2 by 2, which means 2 rows and essentially 2 columns. To get the first answer here, that's in the first row, first column, ultimately we're going to take the numbers that are in the first row of the first matrix, multiply to the first column of the second matrix. So you pair them off. There's 3 numbers going up and down, there's 3 numbers going left and right. So 2 times 2 is 4, negative 1 times 3 is positive 3, and 5 times 5 is 25. And those are the 3 numbers I'm adding here. To get this number, it's the same row, but now times the second column. So 2 times 4 is 8, negative 1 times 6 is negative 6, and 5 times negative 2 is negative 10. And that's here. You add them up essentially and you get negative 8. And the first one you add them up and you get 32. And essentially that's all there is to it now. Second row, now down here, it's the second row times each column. The second row times each column to get these 2 numbers. So these 3 numbers times these 3 numbers from left to right, from up and top to bottom. 12 minus 9 minus 20. And that's where I got this. And the last one is second row times second column. So 6 times 4 is 24. 3 times 6 is 18. And then negative 4 times negative 2 is positive 8. So that's what I did here. And then I compute all these values and I got these 4 members in this matrix. That's all there is to it. Second matrix, second problem here. They have this is again 3 rows by 4 columns. This is 4 rows by 2 columns. So the interior numbers match. So the answer is going to be a 3 by 2, which means 3 rows and 6 columns. So it tells you how big the answer is going to be, and it tells you how it's going to look. So this is very useful. So I take the first row, which is these 4 numbers, times the first column, which is these 4 numbers. So again, 5 times negative 2 is 10, negative 10. 2 times 4 is 8. 1 times 3 is 3. 8 times 6 is 48. Then I added those, negative 10 plus 8 plus 3 plus 48, and I got 47. Get this number, these 4 times these 4. So 15, negative 2, positive 5, negative 24. And that's what I get here. And then the middle one is the second row. When you multiply the second row times the first column, positive 2, positive 12, negative 24, positive 32. And that's where I'm getting these answers. The next one is the middle row times second column, negative 3, negative 3, negative 40, and negative 16. And so on. And then the bottom row times each column here gives you these values. You add them up in each row and each entry. You add them all up in each entry individually, and you get these 6 answers. As I mentioned here, because the interior numbers do not match, the number of columns in the first doesn't match the number of rows of the second. It's not possible. So if not, the multiplication is not possible. So I'll just give you a couple of examples just kind of so you can understand what's going on here. So that's a 6.5 part. And ultimately, 6.6, the inverse, they're really inverses of a 3 by 3 and 4 by 4 and so on, but they're very, very, very tedious. And this is more of a college algebra concept. So I'm just giving you the formula of a 2 by 2, keeping it straightforward, and hopefully it'll be easier for you, just understandable here. So if you take a 2 by 2 matrix, which again is 2 rows by 2 columns, also called a square matrix, A, B, C, D represent the elements that live in here. The formula says you take 1 over AD minus BC. Now keep in mind this is AD. A times D is here, diagonal, minus B times C, which is this diagonal. That's actually called the determinant, but it's basically these 2 numbers minus these 2 numbers, and that's what the formula is. Now notice how this box turns into this box. Notice the A and the D get switched, becomes D and A. D on top, A on the bottom. They just get flip-flop. The two numbers that represent the 2 numbers that these letters represent, we're gonna take the opposite signs of them. That's what the minus is here. So these 2 numbers, we switch the signs. These 2 numbers, whatever they are, we just change the order they're in. If in the formula the bottom becomes 0, then this thing has no inverse because you cannot divide by 0. This thing here is a scalar. It becomes a number that you multiply to each number in the matrix, and that's how you get the inverse. There's a whole issue of how you take the original one and you multiply by its inverse, and you should get the matrix 1, 0, 0, 0, 1, 0, 0, 1, which is the identity matrix under multiplication. I'm not going to get into so much details here because you all have a lot to do with the business part in chapter 5. So I'm going to keep it simple. Let's suppose I wanted the inverse of the matrix that has 3, -2, -8, and 5. This formula here on the bottom says take 3 times 5, which I did, minus these two numbers, which I wrote right here. So that's this part of the formula. Then from this box to that box, notice the 5 and the 3, or the 3 and the 5 become 5 and 3. They get flip-flop. The -8 and the -2 change to the opposite sign, but they stay in the same place. So +8, +2. When you take 15 here and you subtract 16 from it, you get -1. +1 divided by -1 is -1. So this means now take -1 and multiply to every number in the box, basically change the signs of each of these, and that's your answer here. This is the inverse. Okay? Number 2, same kind of thing. I'm sorry for the mess here because I did something wrong. So I don't really like to use pen too much, but it comes up better on the video. So you have 9 and 3, 1 over 9. Again, the formula says multiply these two numbers. So I did 3 times 9, but multiply these two numbers, which you get 27, minus, then you multiply these two numbers, which you get 24. 27 minus 4 is 3, so this is 1/3. The 9 and the 3 flip positions, and you end up 3 and a 9. The +4 and the +6 become -4 and -6. It's staying in the same place. So now I have 1/3 times all of this. Now these are integers. So we multiply a fraction that has a 1 on top. It basically means put a 3 under each one of them. And that's what I did. Now 3 over 3 simplifies to 1. -6 over 3 simplifies to -2. 9 over 3 simplifies to 3. -4 over 3, I just left it as it is. So this is the inverse. And now number 3, when you run the formula, when you crisscross 24 minus 24, you get 0. That would be what's called the determinant. So if the determinant is 0, 1 divided by 0 doesn't exist, not possible. So this inverse doesn't exist, which means the original box inside has no inverse. Now, the -1 symbol meaning, of course, inverse. That's the symbol for inverse. So this is a conclusion of 6.4 to 6.6. It's a very short idea, but I threw some problems in there into your quizzes and threw some problems in there for your tests and your homework as well. So hopefully this will help.